Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Welcome back to part 3 of this micro tutorial series. So we started off, in part 1, and then we kind of got a general overview of a microprocessor. And in part 2, we kind of created the schematic, right? We kind of arranged the various components and then established connection between them. So in this section, actually, in this part 3, what we are going to be doing next is that we are kind of going to actually build our CPU or our control unit to kind of be able to move data around. So that's what we'll be doing, designing the control unit. So yeah, and then I would like to say a little about so let's see how it's going to be like. You see here all these pins that we brought out here. So these are going to be input to the control unit, and then these will be output, right, to kind of the control signals, right? So that will be the output from the control unit. But in addition to, okay, so let me talk about the first two this thing, right? So here, this is a current instruction of this 4 bits, and then other 3 bits is what for the micro instruction counter, right? And then we say this 3 bits, right? The purpose for having these 3 bits here is like it's for when the CPU need additional inputs, additional feedback from the system. You see, so for instance, for now, because we don't have any flags or like the flag register, maybe the carry bit and all those stuff, they normally come from the ALU and other flags. So now I didn't add an flag register for that. So, but at the end of the day, we need additional, inputs or additional feedback from the system. So that's why this 3 bit is for. Just in case, and then you need them later when you're implementing other instructions, especially when you're working your control unit, maybe some other conditional jump and those stuff. So other instructions will require that you get additional feedback from the system, right? So what it means is that the control unit, in addition to the current instruction and then the micro instruction counter, the control unit also get some input from from the data bus also, or from the rest of the system, right? Yeah, so these are the control signals inputs. Yeah, not signals, I mean the additional inputs. Yeah, they can also be signals too. Yeah, so these are additional inputs. Just you will see how we use them. Even though for the instructions I'm going to implement, we might not actually be used. We won't use this 3 bit actually. For the instruction that we'll be implementing, we will not use them because they will not need them, but I'm just putting it in place, as a template. It will be needed, especially when you're working with your table, your final CPU, when you're designing your CPU, right? So it will help you so that because if it's not there, like later it will make it difficult for you to kind of add additional instructions or something like that. So that's how I'll have it here. And then so now in this case, our CPU, apart from the control signal, you can see that these are the only output to it, right? But in addition to these outputs, the CPU also actually doesn't only send control signal, it also generates data. I mean, it's also generate data and send it to the rest of the system too. So what it means is that in addition to these control signals, right, depending on the instruction that you'll be having, if you see the need that you need to send data back to the system, then you will need to introduce those additional outputs, right? So normally for the system design like this, additional 3-bit output will be cool. That one, yeah, you can use it to kind of send data back to the system. So that's what I'm saying. So you have to, the CPU doesn't only send control signal, it also kind of generate data and send it to the rest of the system too. So to send data, you need those additional outputs. This thing, yeah. So I think that should be it. So you use here, right? So control units are kind of implemented in different ways, right? Even though the main function they'll be playing is decoding instructions and executing them all, in other words, generating control signals and sending it, and then also transmitting other data to the rest of the system. That's that function, but how these things are implemented differ like there are different ways to implement it now. And normally the implementation depend on how you are creating your data path, right? How you connect the components is kind of what determine, you know, how you implement your control unit. So that's why I said these connections are very important and crucial, right? In an actual system, a lot of, there's a lot of analysis that go through before you can even establish your connections, right? So but okay, so that out of the way, let's see, kind of, determine, it will kind of have a lot of influence on how our control unit will be designed, right? So let's see, what next do we start doing. So quickly, what we'll start doing is that we're going to first start creating the instructions that our control unit will be executing, because without an instruction we cannot, design a control unit. I mean, there's nothing, a control unit will be useless without it. So let's start creating the instructions for our system. So we are going to kind of create our instruction set. I mean, let's see. So I have a blank, page open here, and we will start writing the instruction and then writing some description about it. But before that, I would like to show you, I would like to show you a typical, instruction set, on an actual micro, controller, right? So let's see. So what I have here is the AVR instruction set. Now, if you don't know AVR, they actually like Atmel or something. They create this. If you heard of the Atmel, the 80 mega or something like that. This 80 tiny and all these chips that are created by Atmel or AVR, right? So, and they all execute these AVR instruction sets, right? And then this is the instruction set manual I have here. So I want you to see how a typical instruction is like. So let's see the add instruction let's see the add instruction, how it is like. So if you see here, this is the AVR add instruction. You see, so this is just a little description about the instructions, and then here, as you can see, these are like, you see, after every instruction executed, right, it has an effect, like you kind of list some of those registers or file that will be affected by the instruction. So these are just some description, but I'm not going to talk about them. I just want to see the little description about the instruction itself. See the add, for instance. Say, well, add to register with all the the carrier flag, and then places the result in the destination register already. Now look at the syntax, right? The syntax of the add instruction. So how does it look like? You see, it says add, then destination register, and then the register, the other register. And so let's see. So okay, let me just take a look at another instruction too, so that you can see. So I want to look for easy instruction that you can use. So let's see the jump instruction, right? So this is the unconditional jump instruction. So let's see what it does. So jump to an address within the entire 4 megabyte words, okay, program memory. So you see, this is, take note of it, program memory. So now here, the size of that program memory is 4 megabyte or something. I don't need to go so much into details about the admin or this thing, but see that it's a program memory actually, or the instruction memory. That is one thing you should take note of, the instruction memory, right? So this instruction is not okay. Let me forget about that. So now see the operation of it, right? And after this instruction executes, let's see the syntax of the instruction. So okay, as I was saying, so normally microprocessor, in the first place, before you can design a microprocessor, you must have some set of instructions that those things must be planned already. Like you should have all your instructions and things in place. You have described them, and then everything is all in place. And before you now implement the microprocessor to kind of execute those instructions. So that's one thing, right? So I could have chosen to just say, oh, let me just try and then build or design our microprocessor here to kind of execute an AVR instruction, so to be based on AVR instruction set, right? But because of this instruction, like AVR, let's say there are a lot of instructions here, and then some of them are kind of a little complex and things, and to avoid confusion and all those stuff, I wouldn't really implement several instructions from here. So for instance, I'll use the jump instruction, which is simple, right? And then the other instruction will just be our own custom instruction, just our own custom one, right, to make things easier for us. so I don't want to kind of worry you so much about these things. So our first instruction is going to be jump, so the same, so it's basically going to be the same thing. And then let me just put instruction 1, that will be so CPU instructions. Okay, this time. So the CPU instructions will be this, right? And let's take the first instruction, which is going to be jumped. So this is just how I do it. I call it jump. This is JMP, right? And then next, we want to give it a little description, what it will do. We see we have to describe it, and so we'll use this as a guide to kind of give so jump to our address within our entire. So it's the same description we'll use to our jump to is into jumped. So description, just for descriptions, right? You can see description. So we have is into jump. So so this is a jump, the form of it, right? It has the instruction and then the location that you want to jump to the key, and then the range of this key actually is so from 0 up to what the maximum number of bits used to store 4 megabytes of word. So yeah, so to store, so kind of store to address 4 megabytes of memory, that you need about, let's say, 16 bits. So maybe k will range from what, from 0 up to what, to raise the power 16, right? And then this is the form of this operation. This is how the syntax is. So the first 16 bits is the instruction, and then the next 16 bits will be the location, the key where you are jamming to.